Ladies and gentlemen, the shipping industry faces increasingly strict greenhouse gas emission regulations on the path to achieve net zero emissions by 2050. And we sense that wind-assisted propulsion technology is stepping into a focus. But why this new interest? Well, probably because wind is a renewable and completely free source of energy. For ship owners and operators, wind-assisted propulsion offers an attractive way to comply with regulations that not only impose cost on emissions, but also require the use of pricier, low greenhouse gas intensity fuels. This way, the obtained fuel savings support to reach a compliance with key initiatives like the EU ETS and Fuel EU maritime regulations, and most probably also the forthcoming updates from the IMO. Today, here with us is Chris Hughes, decarbonization specialist at Cargill Ocean Transportation. He brings with him a vast experience as one of the first movers in the industry pursuing, installing, and operating wind-assisted propulsion. Good day, Chris. It's nice to have you here with us.
Hi, Jose. Look, thanks for the invitation. Always happy to talk about wind propulsion. I think you and I could probably talk about it for hours. I'm going to try not to geek out too much here. Yeah, Chris. According to my records, your original plans to fit an MR tanker with sails date back to the summer of 2020, right in the midst of the pandemic. At that time, only a handful of ships had installed wind-assisted propulsion, making Cargill really one of the early pioneers. I'm wondering what gave you the confidence to pursue this decision back then, and what was your game plan at that time? Yeah, good question. I think it was before I joined Cargill, so I can't take the credit, but I can kind of speak about it. I don't think it was kind of so much a confidence, because I think when Cargill kind of started down this journey and got this interest in wind, we didn't really have a solution in mind. I think it was more driven by a desire to innovate, a want to kind of show what's possible within the shipping industry and really accelerate the decarbonization. And coupled with that, kind of a willingness to actually kind of step out of the comfort zone, take some risk to kind of try and make things happen. We thought someone had to step up, and Cargill could potentially be one of the people to do that. I think, why wind is kind of, it started earlier. I think it was around about 2017 with some work that Cargill did with DNV at the stage, looking at kind of all the different ESD options that are out there and decarbonise options that were on the table. And I think wind stood out as one of the only kind of options that could offer, more than 10% savings. So I think that was kind of one of the interesting things. And also it kind of showed that we thought it could be competitive from a cost perspective as well. Okay. Wind-assisted propulsion requires a significant upfront investment, doesn't it? With high capex, but notably low opex, as the fuel is virtually free. Today, we see leading manufacturers scaling up their production, and that has the potential to reduce the capex in the long run and make the technology more commercially attractive, perhaps. So what do you think would be a tipping point for the industry in terms of achieving a favorable return on investment? Yeah, I think capex is always important. But I think at least the approach we take for wind propulsion and a lot of other kind of decarb technologies as well is we're more focused on kind of the ROI, the payback period, or dollars per ton of CO2 abated. We use these kind of measures that are more of a balance, a ratio between your capex and your opex savings. I think the capex of building the sails is and should come down with time, like you said, as kind of scale effects kick in. But I think at least from our perspective today, I think we see there's more challenges around on the capex side around the installation costs. So particularly around retrofits, it's still a big component of that cost. So one of the things we're looking at is how we can kind of get that down. Less of a problem with new builds, but still, where we want to retrofit vessels as well as new builds. And then on the OPEX side, I think that the biggest question mark and challenge we're facing at the moment is the uncertainty about what are those savings. How much are we going to save if we put this technology and operate it on this ship in this way? And then the other part as well, like any new technology, is what we talk about as RAMs, the reliability, availability, maintainability, and safety. And so I think these technologies are still pretty new. We've still got a fair bit to learn there, and how much that affects the OPEX. So I think where we are today is we see the payback periods, at least for us on a tramping bulk carrier, are kind of too long. So we haven't reached that tipping point yet. We think that tipping point is going to be driven by regulations. And that's essentially what we're doing with the experimentation we're doing now is getting ready to be able to scale once those tipping points come into place.
So it sounds as if, even though we have at hand highly advanced modeling approaches, still an amount of variability and uncertainty is involved, right? But So let me come to my next question. I think we can say that we are kind of witnessing a renaissance of sailing and shipping, but I'm still hesitant to call the ships equipped with sail technology sailing ships. What is your own outlook of how dominant sail systems will or could ever get on cargo ships?
Yeah, that's a good point. I like renaissance. I get tripped up a lot because I talk to people about this great new technology we're working on, which is wind propulsion. People go, hang on, this is not new. So I think a renaissance, I might borrow that. In terms of whether they're sailing ships or not, I think that's a really fair point as well. I think there's some really cool projects that other people are doing in the industry around what we call kind of primary wind propulsion, which are really kind of sailing vessels, and I think that's great. Where we are focused on at the moment is what we kind of talk about more as wind assist propulsion. And we think, again, within kind of our sector, that's how we can have the most impact. That's how we can scale up on more ships and basically reduce the most CO2 in the kind of the medium term and have the most impact. So what we're looking for is this kind of sweet spot between bigger savings and that ROI, that payback period that I was talking about before. What we're finding through kind of the work we've done and the experimentation we've done so far is that today it's doable to put wind propulsion on a bulk carrier with kind of more modest savings. We've done that. The NBA Marguerite project that we've done there is a really good example. That's really doable today. But I think what we're finding is if you want to get those bigger savings, 15, 20, 25% more savings, which is kind of where we're trying to push ourselves outside of our comfort zone and work out how to do that's definitely harder. And there's a few reasons we're finding, we're kind of learning on that. I think one of them is kind of on the ship design side, particularly with the retrofits, you kind of hit limits. We on the Pyxis Ocean, they're big, powerful sails. We're kind of running the engine at kind of the minimum load a lot of the time. We're getting pretty big leeway angles and rudder angles, which gives you drag. So you get these kind of losses of efficiencies as you go too big. I think the other area where we've got challenges with going bigger is around the port interface. And this is something that I think is specific to bulk carriers. Getting the sails out of the way to do loading and unloading operations is critical. It's difficult to do, and it's really important you can do that. So again, this is probably one of the biggest challenges we're kind of working on at the moment. How do we get bigger, more powerful, more sails, bigger savings, but at the same time kind of fit within the port infrastructure that's there? Because we're happy to kind of disrupt ourselves, I think, to try and make this happen, but we don't want to kind of just expect the whole supply chains that we serve to have to change to kind of fit our wind ships.
Yeah.
Sorry, that was a bit long.
So, no, really interesting perspectives that you're sharing, Chris. But While you mentioned Pyxis Ocean, I saved this one for last, and I'm really certain that our audience has been perhaps waiting for this question. But with your ships, you've gone through some trials. Can you share some numbers, please? So how much does wind-assisted propulsions actually save in terms of fuel or CO2 as peak or in average in your cases?
Yeah. Okay. Yeah. Look, I thought we'd probably kind of get to this. Everyone always wants to know the numbers. Look, so I'll start with kind of the cool parts and the interesting parts. I think, we think these things work. We've had savings. The first voyage for the Pyxis Ocean and the first voyage for the TR Lady as well with the rotors. Both of those, straight out of the shipyard, we were getting really great savings, 20-30% plus. I think maximum kind of 32% on the Pyxis Ocean because we got lucky. We got some really good conditions on those. So, that's awesome. But I think the approach we're taking is the business case for this is based on the average savings you get. And so we're not so worried about whether it's 2% or 20% we're saving on these voyages where we're doing the experimentation. What we really want to do is kind of validate the models that we're using in our simulations. And then once we trust those simulations, we can use them to make better decisions, to trust our business models. So I think on the Pyxis, the way we worked is we did a lot of on and off testing in those kind of initial experimentation phases. We did those with the supported DNV. And I think what we learned from that is that we could trust the models that BAR had the simulations and the savings that come out of the simulations from BAR. And I think that's pretty impressive, that they were right pretty much outside of the box. I think the other thing we learned is it's difficult to do accurately, but if you do enough of these tests, you can trust the models. And the way that worked is we run those if we run those models for the Pyxis Ocean on a typical Kamsarmax routes over a long period, what that says is we should be saving around about 3 tons a day for that vessel on those routes. But I think one of the reasons why I'm kind of giving you a bit of a long-winded answer there and are reluctant to give kind of figures is because, there's really 2 parts to the savings you get out of these technologies. One is what the technology does as itself, but also like what you do with that ship. So just because it's 3 tons on the Pyxis doesn't mean that someone else operating a ship on different routes in a different way can't be more or be different. Yeah.
And it's all about statistics also, isn't it? So I understand that your point is also verifying the theory of predictions that you were given in early project stage seems at least as important as the actual saving numbers themselves at this stage.
Yes. Yeah, definitely. Yeah.
Quick very last question to you. What would be your key message to our audience?
Okay. I'd say, look, I think we've learned a huge amount with the 3 vessels that we have on the water so far, but we haven't finished learning yet. We don't have all the answers. We're still doing more experimentation. I think we still, having gone through that process, we still believe in our original thesis that wind has and can play an important role in the decarbonisation of shipping. It can be a competitive way of complying with those regulations and reducing the cost of decarbonisation. I think I've got to give a big shout out to everyone that we've worked with, all our partners through these projects. We definitely haven't done these alone. And look, on the Pyxis Ocean, we work very closely with MC Shipping, the owners of the vessel. And I think that's a great example of what I call a true partnership kind of collaboration that you need to kind of make these things work. We're on the same page. It's a real collaborative risk sharing agreement there. So I think we haven't finished experimenting yet. I reckon we've got at least another round of experimentation in us for wind before we scale up. We always need like-minded partners. So, for the ship owners out there, if you're on the same page as us, you're willing to be bold, courageous, take some risks and innovate, let's talk.
Yeah. Chris, I really have to express a huge thank you for being with us today. The experience you shared was really extremely interesting and hopefully also inspiring for the audience. Thanks a lot.
Thanks, Hasso. It's good to talk.
With that, back to the studio.